Bismillahirrahmanirrahim. Today we are starting with the concept of resonance in chemistry. The resonance is actually the shifting of electrons in between fixed atoms in a molecule. Resonance can produce an increase in electron density and then correspondingly a decrease in electron density in a molecule to produce a mesomeric effect. You can see the examples here in case of benzene. Here, these are the pi bond, are the pair of the electrons represented by bond. Here, there is a shifting between 2 and 3 atoms. And then from 3 to 4, the shifting to be 4 and 5 atom. And in between 5 and 6, the shifting now occur to between 6 and 1. And so due to these shiftings of the electron, we get an other resonating structure. Similarly, in case of the molecule like this, here we have the conjugate bonds. This is the double bond. After this, we have the single bond and then double bond. Such a system is called conjugated system or alternate of the double single bonds. And in such type of the molecule, the resonance can occur. If we move 5 electrons here, we get this, and corresponding decrease of electrons near the carbon will compel the shift of the electrons here, and then we get deficiency of electron here and the increase in the density of the electron here and double bond shifted in between. So in case of phenol, here we are presenting the resonance. The lone pair of the electron at the oxygen would shift here, and this pi electrons would shift at the corner here at the ortho position, and we will get this resonating structure. Similarly, from here, it would shift in between, and then correspondingly, it would shift here. We will get the third resonating structure, and similarly, shifting from here and then shifting from here, we are getting the fourth resonating structure. So if we replace this OH electron, which is having lone pair of electron, by NH2, the lone pair is also present on the nitrogen here. OCH3, also we can see here the lone pair. SH, we can see here the lone pair of electron. And any halogen like Cl, here we can see the lone pair of electron. So if we replace this OH by NH2 OH3, then the same we can get the resonating in structures like 2, 3, 4. Similarly, if we have charge on oxygen, then simply it will shift to give the double bond here, and the shifting would be here. We will get negative ion here, and so the the resonance would proceed like that one. So if we replace O minus by NH minus, S minus, the same kind of the structure like 2, 3, 4 we will get. But if we have electron withdrawing type of the group of the elements or the atoms like nitrogen and nitro group. So the structure of the nitro group is like this. So the electrons from NO will shift to O, and then from here, shift to here, we'll get this. And unlike this and this, we would get positive or the deficiency of electron at this position. And to cover the deficiency, the electron will come here and we will get positive here, and then from here to here, then positive here. So just like nitro group, if we replace the nitro group with cyanide or aldehyde group, so same sort of the resonance would happen, and the structure like 2, 3, 4 will appear as in case of nitro benzene. So in case of this molecule, the electron density of this carbon is high, and here we have the deficiency of the electron. Here we have the double bond, which is alternating with the charge density here, and similarly alternating with the deficiency here. So double single deficiency of electron, double bond, single bond, deficiency of electron. So resonance can occur. So the electrons come here, this will come here, and we will get this type of the resonating structure here, the neutral molecule. Similarly, we have the conjugated system, double bond, single bond, double bond, single bond, and this double bond is in conjugation with the deficiency of the electron. So the resonance can happen like this. Double bond shift here, then this pi bond shift here, will get the structure like that one. Similarly, as we know, the halogens have the lone pair of the electrons, for example, in case of chlorine. So this pi bond is alternate with this lone pair of electron. So the resonance can occur. This triple bond having two pi bonds is alternate with this double bond. So the resonance can happen. So if one pi bond shift here, because the electronegativity of nitrogen is high, the bond would shift here, and then this would shift here, this would shift here, and this way we get the negative here and the positive here. So this is the mesomeric effect also, because at one position there is enrichment of the electron, then density of electron is increasing, and correspondingly at another atom, due to this effect, there is occurring the deficiency of electron. Similarly, simply the conjugation in this molecule, this is the diene. So this pi bond alternate with this pi bond. So this can shift here, this can shift here. In this way, we can get the electron deficiency and an electron density increase here, and we get the resonating structures. So for resonance in a molecule should be planar. The pi bonds in the molecule should be at alternate position, or they should be conjugated to each other. Similarly, any positively charged atom, any negatively charged atom, and an atom with the lone pair of electron should be conjugated to pi bond or any other deficient position, or high electron position. So in this way, the resonance can occur. The resonances actually can occur in the molecules, which should be planar and which should have the conjugated system of the electrons movement. Pi to pi conjugation, electron deficient site to pi conjugation, electron rich site to pi a conjugation, or electron rich site to electron deficient site conjugation would give you the resonance, give you the resonating structure, and in this way you can explain the phenomenon of stabilization, and this can help you in finding the reaction kinetics and the stabilization of the molecules. Thank you very much.